for the review. We're doing just a bunch of practice problems where we're reading, interpreting, and trying to figure out how to get the answers from interpreting. A line L passes through point A and is parallel to the line R. Now, whenever you see R, what do you replace R with automatically? There you go, X, Y, Z. Just makes everything easy, doesn't it? Now you can see the parametric coming through. But this one is R equals A plus T times B. And you're going to notice a real similarity to your lab, how this all works together. So we're going to start with X, Y, Z. And this one, this line L, goes through point A. So who is the center of the universe in here? Abby was. So Abby to a point on the line would be a vector from origin, 0, 0, 0, to a point. In this case, it's A. So we just put 1, negative 1, 2. Now all we need is a direction vector. Well, it says it's parallel to this one. So which one, green or purple, is the direction vector? Purple is. So that's going to be 1, 3, negative 2. Done. That's it. Boom. You've got yourself a vector. Then it says, find the line passes through a point, P, when T equals 2. Well, the whole point of this vector equation is to generate points. So if T equals 2, X, Y, Z is equal to 1, negative 1, 2, plus 2 times 1, 3, negative 2. So you can kind of see how slick this is in calculating. 1 plus 2 is 3. Negative 1 plus 6 is 5. 2 minus 4 is negative 2. So my point P is 3. 5, negative 2. Okay. So if you're finding point OP, all that you do is you put in, for T, put in a, for T, put in a 2. And so when you add across, you're going to get X, Y, Z equal to 1 plus 2 is 3, negative 1 plus 6 is 5, and 2 minus 4 is negative 2. So that is vector OP. The point is 3, 5, negative 2, but they're asking for point OP, or vector OP. And to find the magnitude of that, you're going to take the square root of 3 squared, 5 squared, and negative 2 squared. And that'll get you square root of 38, which is OP. Now we're going to talk about making a unit vector. If OP is the square root of 38, we can turn it into a unit vector by dividing this whole thing by square root of 38. But we'll get to that in a little bit. You try practice set B. Pause this if you're on the computer. Try A, B, C, and D, and then we'll go over them shortly. Going through just A and B quickly before you try C and D. A, B, think of this as a vector. The arrow is pointing toward the B, so where's the head at, A or B? What's that? B, that's where the arrow is. So this is the head, this is the tail. So normally a vector has its tail at the origin, but this one has its tail at A. So if this is the origin, 0, 0, 0, and then this is A, actually that's a point, so I would probably write it this way, point 0, 0, 0, and then point 1, negative 1, 4, and then point 2, negative 2, 5. Okay, now what happens here is that we want this vector here, we want this vector to be at the origin. So if we're moving this vector to the origin, you're taking this 2 and you're reducing it by 1. So then it's back to the origin. And you're taking the negative 2 and reducing it by this, and the 5 reducing it by 4. And that moves it. Is this the same vector? Is it easier to deal with if the tail's at the origin? Big time. So you're just going to go 2 minus 1, and then you're going to go negative 2 minus negative 1, and then 5 minus 4, which is just 1, negative 1, 1. That's AB. So then for L1, you're going to go X, Y, Z equals point A. Let's go with A here. 1, negative 1, 4, plus direction vector. Which is the direction vector? For AB. 1, negative 1, 1. So here was my original point. Here is the direction vector. So there's your L1. And then you have L2 right here. You'll have XYZ equal to 2, 4, 7. And then S is going to be 2, 1, 3. And those are the two lines. Now, what part of those will be helpful for finding the angle? What will be helpful for finding the angle here? The direction. Is that 1, negative 1, 4 or 1, negative 1, 1?
1, negative 1.
There you go. And then the other one is going to be 2, 1, 3. That's all you need. The cosine of the theta, which I'll give you as a formula, is A dot B over magnitude of A over magnitude of B. So this is like your little A, and this is like your B. So go ahead and use your formula and finish that. So in calculating that angle, you're going to take the dot product of the direction vectors. 1, negative 1, 1, dot, 2, 1, 3. This will help us to find the angle. But you got to divide by the square root of 1 plus 1 plus 1 and the square root of 4 plus 1 plus 9. So as you do your cross product or dot product, you just multiply across and add 2 times 1, negative 1 times 1, 3 times 1, square root of 3, square root of 14. So the cosine of theta is going to be 5 minus 1 is 4 over the square root of 42. So would you take your calculators, what's inverse cosine of 4 over the square root of 42? What'd you get for an answer? About 52 degrees. That's the angle between those two lines. Are you good with that? You all right with that? And so what the dot product is you take the x1, x2, y1, y2, z1, z2, and then multiply and add them up. And that gives you the dot product. If it's negative, you're going to be between 90 and 180. If it's positive, it'll be between 0 and 90. So now that we have this, we got the last part. It says the lines L and 1 intersect at point C. Find the intersection. So we're going to break both of these down into parametrics. X equal 1 plus t, y equal negative 1 minus t, and z is equal to 4 plus t. And then we're going to have x is equal to 2 plus 2s, y is equal to 4 plus s, and z is equal to 7 plus 3s. And then we just go x equal to x and y equal to y. And watch what happens. here you're going to have 1 plus t is equal to 2 plus 2s. I like to, let's subtract 1 here. T is equal to 1 plus 2s. I like that. And then for y equal y, I get negative 1 minus t equals 4 plus s. Okay. And then I would add 1 here. Negative t is equal to 5 plus s. And let's just take these in a column and add them up. 1 plus 2s, negative t equals 5 plus s. If we add them up, you're going to get 0, you're going to get 6, and you're going to get 3s. So negative 6 equals 3s. S is equal to negative 2. And if s is negative 2, then t is going to be 1 plus 2 times negative 2. 1 minus 4 is negative 3. T is negative 3. But it doesn't matter because what we're looking for is the actual intersection. So for that intersection, you just take either one of these. Let's take the s here and put a negative 2. 2 plus 2 times negative 2. 2 minus 4 is negative 2. 4 plus negative 2 is 4 minus 2 is 2. And 7 plus 3 times negative 2, or 7 plus negative 6 is 1. I get a point, C, of negative 2, 2, 1. Let's check it out with the t. If we put a negative 3, what's 1 minus 3? Negative 2. What is negative 1 plus 3? 2. And what's 4 minus 3? Negative 2, 2, 1. It works the same. So we know we did it right. Either one of those will be right. Work. Any other questions on that? That's the hardest one, isn't it? The intersection. Yes?
How can it?
It's before.
Oh.
All right. So you know how to find the angle. You find the direction vectors. And once you know the direction vectors, you can find the angle. One's A, one's B, dot product over magnitude, magnitude, inverse cosine. If you're looking for intersection, you put it in parametric for each of them. Okay? Then you set the x is equal to x, y equal y. You have two variables, two equations, two unknowns. Then you can solve for either one, and then you plug that into either one, the one that's appropriate, and get that intersection point. But both will work out. You try the last set here. All right, let's see how you did it. A, B. So here's A, here's B, and here's C. So you have one vector that's AB, one vector that's AC. You want vector BC. So which is the tail, B or C? B is the tail, and C is the head. So remember when we said go head minus tail? You can do that here for BC. Head is AC. Negative 2 minus 6 is negative 8. Negative 3 minus negative 2 is negative 1. And 2 minus 3 is negative 1. How many got negative 8, negative 1, negative 1? Good. Do you want to see another way that this makes sense? Now this made total sense when it was just two coordinates. But when they're vectors, it seems a little weird, doesn't it? But look at how this makes sense. What you're essentially doing to go from B to C is you're going back to A, and then you're going over to C. Do you agree with that? So what's happening with AB? AB is this way, but we're going from B to C. So do you get how we're going back AB? And then we're going forward AC. So it's AC minus AB, or head minus tail. It works either way. Isn't that neat? Vectors are really clever. All right, so next, you're going to find the unit vector. So the unit vector of AB, well, here's AB. AB is 6I minus 2J plus 3K. But I got a problem. This thing is not 1 unit long. It's too long. So let's find out how long it is. What are you going to do with it to make it 1 unit of length long? Well, we'll come to that. So here we go. The magnitude of AB, how long it is the square root of 6 squared plus negative 2 squared plus 3 squared. That is 36 plus 4 plus 9. So that's the square root of 49. And what's the square root of 49? 7. So this thing is 7 units long. What can we do to make it 1 unit long? You divide it by 7, and now it's what we call a unit vector, like that. What if I asked you to make it 10 units long? Now what would you do with this unit vector? Multiply by 10. What if I said make it 110 units long? What would you do? Easy. But you got to shrink it down to 1 first. So remember when we talked about FedEx? Everything is sent to Atlanta, and then it's sent to each place? Saves a lot of gas all around by having that one depot place. So the depot place here is everything goes to 1 unit long, and then we multiply it by whatever we want. Okay, real quickly, could you tell me what the unit vector of AC is? And then let's make AC, how old are you, Taylor, how old are you? 16. 16 units long. So find AC as a unit vector and then make it 16 units long. Go for it. We want to make sure you get this. Show that AB is perpendicular to AC. So AB perpendicular to AC, all you do is do the dot product. The cosine of the angle is the dot product. Well, if it's perpendicular, what's the cosine of 90? 0. So if the dot product, A dot B equals 0, they're perpendicular. So 6, negative 2, 3, dot product, negative 2, negative 3, 2. Let's see what that is equal to. Negative 12 plus 6 equals what? 0. Therefore, perpendicular. And that's my review. Oh, also velocity. If you have a vector xy equal to 2, 5 plus t 7, 4. This is my position. This is my position. What's this thing? Still position. But when you put time in here, this becomes what? In order to go, what times time is position? Velocity. So if you take the magnitude of that, square root of 7 squared plus 4 squared, you're going to get, I don't know what that is, 65, square root of 65, that's the speed. It's the magnitude of the direction vector. And that should get you ready for the test.